Hello, this is Nikitan, Assistant Professor, Department of Civil Engineering, UIT, Makluri. So today I am going to discuss about pavement materials and pavement design, which is a new module, that is module 3. Yes, here in this slide you can see a picture which is representing different layers of a pavement. So firstly it is a natural ground profile. So above the natural ground profile there is a first course, and that first course is called as sub-base course. So above the sub-base course, base course, and above the base course, surface courses are provided. So above the surface course the vehicles will be moving. So module 3 is divided into two parts. So the first part is highway material and the second part is pavement and design. So today in this session, let us have a discussion on highway materials. So what are the different materials used in the construction of pavements or in the construction of highways, and what are all the properties that we should take care about this materials. So these things we are going to discuss in this session. So firstly, let us see what are the things we are going to study under this highway materials. So firstly we are going to study about subgrade soils. So in subgrade soils we are going to further study about the properties of the subgrade soil and classification of the soil, determination of CBR of a soil, and determination of modulus of subgrade reaction of the soil. Then after studying about the soil, then we will move on to the aggregates. So in aggregates we are going to study about the properties and tests that is conducted to know the strength of the aggregate. And then after the aggregates there is one more material which is used in the construction of pavement, that is bituminous material. So here under this part we are going to study about what is bitumen and what is tar emulsion and cutback bitumen, and what are all the different tests that is conducted for this bituminous materials. So highway, pavement materials. So introduction. So pavements are conglomeration of materials. These materials, their associated properties and their interaction determine the properties of the resultant pavement. So pavement means we know that it is not constructed with a single material. So pavement is constructed with the different materials. So here the pavement are conglomeration of materials means the pavement is constructed with using different materials. So here what we need to know is the different materials which are used in the construction of pavement, and we should know the properties of these materials, like what is the strength of a material, density of a material, and what is the interaction of a material with other materials, etc. So if we know the properties of these materials, then these materials can be effectively used in the construction of pavements. Then we can expect a good pavement. So a good understanding of these materials, how they are characterized and how they perform is fundamental to understand the pavement. So a person who involves in the work, or an engineer who is responsible for the construction of highways or pavement, should know about the material properties, and you should know the fundamentals about the materials which is used in the construction of pavements. And the materials which are used in the construction of highway are the intense interest to the highway engineer. As I told, the engineer who is involved in the construction of highways should be aware of all the properties and characteristics of the material. Then only it can give a effective pavement which lasts for a long time. So this requires not only a thorough understanding of the soil and aggregate properties which affect pavement stability and durability, but also the binding material which may be added to improve this pavement features. So here in pavement materials, it is not only important to know the properties of aggregates and soil which is used in the construction of highways. It is also important to know the properties and ability of a binding material which is used in the construction of highways to bind different materials like aggregate and soil. Hence, a person or engineer involving in the construction of highway should also be aware about the characteristics and properties of a binding material. Then only we can improve the pavement effectiveness. Now let us see about subgrade soil. So subgrade soil is the first course of the pavement above the natural ground surface. So soil is an accumulation or a deposit of earth material derived naturally from the disintegration of rocks or decaying of vegetation that can be excavated readily with power equipment in the field or disintegrated by gentle mechanical means in the laboratory. So we all know that how the soil is deposited and how the soil is formed on a earth surface. So soil is the resultant of a decaying of a rock or decaying of a vegetation. So the soil which is used in the construction of pavement can be readily excavated nearby the site of construction, or the soil can be obtained from the field equipment by disintegrating the rock if it is available nearby the construction site. So it is an integral part of the road pavement structure as it provides the support to the pavement from beneath. So subgrade soil is the integral part of a road pavement. So main function of this subgrade soil is to take up the load which is coming from the top surface and to distribute the load onto the ground surface safely. So the main function of subgrade is to give adequate support to the pavement, and for this subgrade should possess sufficient stability under adverse climatic and loading conditions. So as I said, the main function of this subgrade is to take up the load which is coming from the top surface of the pavement and to distribute among the natural ground surface. So to do this, we should provide a subgrade soil with high strength. So it should possess a sufficient stability under a different climatic condition, and the soil should not undergo failure during different loading conditions. So here the formations of waves, corrugations, rutting and showing in black top pavements and the phenomena of pumping and consequent cracking of cement concrete pavements are generally due to poor subgrade conditions. So if subgrade soil is of good quality, then we can expect a good pavement surface. So desirable properties. So what are the properties of a subgrade soil which is used in the construction of highways? So the desirable properties of subgrade soil as a highway material are stability, incompressibility, permanency of strength, minimum change in volume and stability under adverse condition of weather and groundwater, good drainage and ease of compaction. So here the soil should possess adequate stability, or it should resist permanent deformation under different types of loads, and the soil should possess resistance to weathering. So what will happen? The soil can regain or retain its strength. So when the soil is having a good stability, then there is a minimum variation in volume with variation in water content will ensure minimum variation in differential expansion and differential strength values of the subgrade. Also, the subgrade soil should provide a good drainage facility to drain off the rainwater which is percolating from the top surfaces. So the soil which is used in the construction of highway should have a good compaction ability. Then only the percentage of voids which is present in the soil can be removed. So these are all the desirable properties of the soil which is used in the construction of subgrade. Now next coming to the classification system of the soil. So here the soil is classified under different systems. So firstly the soil is classified as based on Burmester descriptive classification. Second one is Casa Grande soil classification. Then Unified and IS soil classification. US Public Road Administration classification. HRB or AASHTO or revised PRA classification. So here HRB means it is Highway Research Board classification, and AASHTO means it is American Association of State Highway Officials classification. Then we have Federal Aviation Agency classification, Civil Aeronautic Administration classification, and compaction classification. So these are all the different classes on which the soil is being classified. Now, among all those classification, the important classification is Highway Research Board classification of soils. So let us see how the soil is classified under Highway Research Board. So this is also called as American Association of State Highway Officials, that is AASHO classification, or Revised Public Road Administration Soil Classification System. So here in this classification system, the soils are classified under 7 groups. That is, the soil is classified from A1 to A7, like A1, A2, A3, A4, A5, A6 and A7. And here A1, A2 and A3 soils are granular soils and percentage fineness passing through 74 micron sieve is being less than 35%. So here A1 soils are well graded mixture of stone fragments, gravel coarse sand and fine sand and non-plastic or slightly plastic soil binders. So in A1 class, the soils are subdivided into two subgroups as A1A and A1B. In this subgroup or subcategory, in A1A subcategory consists of predominantly stone fragments or gravels, whereas A1B subcategory consists of predominantly coarse, coarse sand. And coming to the A2 classification, so A2 group of soil include a wide range of granular soil ranging from A1 to A3 groups consisting of granular soil up to 35% fine of A4, A5, A6 or A7 groups based on the fineness content, and A3 soil group consists of mainly uniformly graded medium or fine sand similar to beach sand or desert blown sand, stream deposited mixture of poorly graded fine sand with some coarse sand, and Gravels are also included in this group. So this is how the soil is categorized under A1, A2 and A3 class. Now coming to the further classes, A4, A5, A6 and A7 soils are fine grained or silt clay soils passing through 74 micron sieve being greater than 35%. So in this category, in A1, A2, A3 category, the soils are granular. When these soils are sieved through a sieve of 74 micron or through a sieve of 0.074 mm, the percentage of soil that passes through 74 micron sieve is less than 35%. Whereas if we consider the soil group A4, A5, A6 and A7, and when the soils of this group is sieved using a sieve of 0.74 mm sieve, then the percentage of passing is more than 35%. So that indicates that the soil which comes under these groups are fine grained soil or it is silty clay soil. So let us see what is A4. So here A4 soils are generally silty soils, non-plastic or moderately plastic in nature with liquid limit and plasticity index values less than 40 and 10% respectively. Whereas A5 soils are also silty soils with plasticity index less than 10%, but here the liquid limit value exceeds 40%. So whereas in case of A4 group, the liquid limit was 40% and in A5 group, the soil is having a liquid limit more than 40%. So A6 group of soils are plastic clay having high values of plasticity index exceeding 10% and very low value of liquid limit below 40%, and they have very high volume change properties with variation in the moisture content. So A7 soils are clay soils as A6, but A7 soils are having very high value of both liquid limit and plastic index, where the liquid limit is greater than 40% and plastic index of A7 soils are greater than 10%. So same thing is being tabulated in this slide. So here you can see, so group classification A1, so A1 is subdivided into A1A, A1B. So here we can see sieve analysis percentage passing. So when we consider 2 mm IS sieve, the maximum percentage of soil passing through 2 mm is 50%. So 50% is the maximum soil that will pass through 2 mm sieve. So if I take 425 micron sieve, then percentage of soil passing through this 425 micron is 30%. So 30% is the maximum. If I consider 75 micron sieve, then the percentage of soil passing through this 75 micron sieve is 15%. So that is the maximum percentage of soil that passes through 75 micron. Similarly for A1B group is also given. So 50% of the soil will pass through 425 micron sieve and 25% is the maximum percentage that will pass through 75 micron sieve. Similarly for A3 group, A2 group and A4, A5, A6 groups are given here. So next coming to group index of soil. So it is also called as GIS or GI. So what is group index of soil? So here we saw that there are 7 classification of soil under HRB. That is under Iowa Research Board we have 7 classes. So the soil is being divided into 7 groups. So in each groups we have some percentage of fine clay or fine soil. So this fine soil is given an arbitrary number under this index of soil group. So fine grained soils of each classification group exhibit a wide range of properties as a subgrade material. So if I consider a A1 soil group under HRB classification, so A1 soil group is having a very fine grained soils. So if I consider that fine grained soils of A1 group, that soil may be having different properties. So to know the different properties of that fine grained soil as a subgrade material, we are going to assign a number for such soils, and that is called as group index of the soil. So in order to classify the fine grained soils within one group and for judging their suitability as subgrade materials, an indexing system has been introduced in HRB classification, which is termed as group index. So as I said, group index is a classification in which all the fine particles or all the fine grained soils are made into a single group, and indexing is done. So this is done to judge the suitability of the soil, that can whether that soil can be used as a subgrade material or it can't be used as a subgrade material. So soils are thus assigned with arbitrary number known as group index. So each soil is given with an arbitrary number, and this arbitrary number is called as group index. So group index is the function of percentage of materials passing through 0.074 mm sieve, liquid limit and plastic index of a soil, and is given by the equation Gi is equal to 0.2a plus 0.005 AC plus 0.01 BD. So what is group index? It is the function of percentage of materials that passes through 0.074 mm sieve, and which is having a liquid limit and plastic index of a soil, and this can be determined by using a equation Gi is equal to 0.2a plus 0.005 AC plus 0.01 BD. So where A is proportion of material passing through 0.074 mm sieve and greater than 35% and exceeding 75%. They are not exceeding 75%. That is, the material passing through 0.74 mm sieve is greater than 35%, and it will not exceed 75%. That is, the percentage of passing should be between 40 0 to 40. So B is the portion of material passing through a sieve of 0.074 mm greater than 15 and not exceeding 35%. So the fine soil, when it is sieved through 0.074 mm sieve, the percentage of passage is more than 15% and not exceeding 35%. It is denoted by P. And C, it is the value of liquid limit in excess of 40% and not less than 60. D, the value of plastic index greater than 10 and not more than 30. So using this equation we can determine what is the group index of a soil. So according to this formula, the minimum possible value of group index is 0 and maximum possible value of group index is 20. So when the value of soil fraction passing through 0.07 mm sieve, liquid limit and plastic index are respectively higher than 75, 60 and 35%, higher the value of group index, poor is the soil as a subgrade material. So lower the value of group index, then it indicates that the soil is good and the soil is suitable for use as a subgrade material. So for example, if group index number is 1, then that soil can be suitable for use in the subgrade construction. If the group index is 15 or if the group index is more than 15, then that type of soil is very poor soil and it is not recommended or it is not suitable for use in the construction of subgrade course. So how to determine the strength of a soil? So up to previous slide we studied what are the different classification of a soil and what is the group index, and now we shall see how to evaluate the soil strength, because the soil when it is used in the pavement construction we should know what is the strength of a soil. So we have different tests to evaluate the strength of a soil. So we have mainly three tests, that is shear test, bearing test and penetration test. So why we are going to test for the strength of a soil? Because we know that a soil is an integral part of a road pavement structure as it provides the support to pavement from the beneath. Therefore, the subgrade soil and its properties are important in the design of pavement. So here the main function of subgrade is to give adequate support to the pavement, and for this subgrade should possess sufficient stability under adverse climate and loading condition. Therefore, it is very essential to evaluate the subgrade by conducting different tests. So the different tests we have many numbers of tests to evaluate the strength of soil, but apart from that the three main tests which is used in determining the strength of soil, which is used in the construction of subgrade course, is shear test, bearing test and penetration test. So shear tests are usually carried out on relatively small soil samples in the laboratory in order to find out the strength properties of soils. A number of representative samples from different locations are tested. Some of the commonly known shear tests are direct shear test, triaxial shear test, compression test and unconfined compression tests. So coming to the bearing test. So bearing tests are loading tests. So here the subgrade soil is tested using a loading plate of relatively large bearing area. The ratio of deformation or settlement of a loading plate to the diameter of loaded area is quite small. The result of bearing tests are influenced by variation in the soil properties within the stressed soil mass underneath, and hence the overall stability of the part of soil mass stress could be studied. And penetration tests may be considered as small scale bearing tests in which the size of loaded area is relatively very much smaller and the ratio of penetration to size of the loaded area is much greater than the ratio is in bearing test. So the penetration tests are carried out in the field or it is carried out in the laboratory. The most common penetration test which is conducted to know the strength of soil which is used in the construction of highways, CBR test and cone penetration tests. So these two tests are commonly used to evaluate the penetration strength of a soil. Okay, now let us see what is CBR test. So CBR stands for California Bearing Ratio Test. So here the CBR test It is a penetration test developed by California Division of Highway for evaluating the stability of subgrade soil and other pavement materials. And the test results have been correlated with flexible pavement thickness requirement for the highway and airfield. And here the CBR test may be conducted in laboratory on a prepared specimen in a mold, or it can be in seat in the field. So CBR test, it is an empirical test and has been used to determine the material properties for the pavement design. So it is a penetration test where a standard piston of 50 diameter is used to penetrate the soil at a standard rate of 1.25 per minute. The pressure up to a penetration of 12.5 and its ratio to bearing value of standard crust rock is termed as the CBR. So here in the CBR test, we are going to use a standard piston of 50 diameter. So this 50 diameter piston is penetrated to the soil, and here what we will do is for a depth of 2.5 and for a depth of 5 we will note down the penetration value. So the penetration is done at a standard rate of 1.25 per minute. Ratio The ratio at 2.5 penetration is used as a CBR value. In some cases, the ratio at 5 may be greater than that of 2.5 If this occurs, the ratio at 5 should be used. So here, the CBR value is considered for a depth of 2.5 penetration. In some cases, what happens? The value of CBR will be more when we consider a depth of 5 millimeter. So in such cases, when the CBR is more at 5 then we should consider the CBR value for the 5 depth. So why we will consider the CBR value at 2.0 penetration is because with increase in the penetration, there is decrease in the CBR value. Hence, we will consider the CBR value for a depth of 2.5 penetration. However, in some soils or in some cases, the CBR value will increase to at a depth of 5 In such cases, we can consider the value of CBR for the penetration of 5 depth. The CBR is a measure of resistance of a material to penetration of standard plunger under controlled density and moisture condition. So here CBR is nothing but it is the measure of resistance offered by the material to penetration of a standard plunger under controlled density and moisture condition. So if I want to know the CBR value or CBR strength of a soil, then the measure of CBR strength of a soil is nothing but the resistance offered by the soil to the penetration of standard plunger under controlled density and moisture content. The CBR test may be conducted in remolded or undisturbed specimen in the laboratory. So we can determine the CBR value of a sample in two cases. One is in remolded condition or in undisturbed specimen in the laboratory. So this depends upon the importance of the project and requirement of the project. The test is simple and has been extensively investigated for field correlations of flexible pavement thickness requirement. So CBR test, it is a very simple test which is conducted in a lab or it can also be conducted in the field. So using the values obtained from CBR test, we can decide the thickness requirement for the flexible pavement. So in this picture you can see what is the setup for CBR test. So this is a specimen and above the specimen we have a surcharge weight and this is a plunger of diameter 50 millimeter. So this is a dial gauge. This is a probing ring. So the load is applied on a soil and readings are obtained in this probing ring. So this is a CBR test instrument which consists of a cylindrical mold, and the diameter of the mold is 150 mm. So a cylindrical mold of diameter 150 mm and 175 mm height, and this cylindrical mold is provided with a collar of 50 mm height. So here we have a collar at the top. So this collar is used when the soil is placed in the cylinder, and when it is compacted, the collar is placed above the cylinder. So the collar is having a height of 50 mm and it is placed above this cylinder, and it is a detachable part. So this cylinder is placed on a perforated base with a spacer disc of 148 mm dia with a thickness of 47.7 mm, which is used to obtain a specimen of height exactly about 127.3 mm. So a loading machine, it it is operated at a constant rate of 1.25 mm per meter, and here you can see a loading frame. So it is a loading frame which consists of a plunger of a diameter 50 mm. So a plunger, here this one is a plunger of diameter 50 mm and a dial gauge for measuring the deformation due to the application of load. So here we have a gauge. So in this gauge we can measure the deformation which occurs on a soil due to the application of load. These are the rammers which is used for compaction of the soil. Now coming to the test procedure. So how the soil which is collected from the site is tested in the laboratory. So the laboratory CBR apparatus consists of a mold of 150 mm diameter with a base plate and a collar and a loading frame and a dial gauge for measuring the penetration value and expansion on soaking. So this is an instrument which is used to determine the CBR value. So here a sample of about 5 kg is taken. So this sample should pass through a sieve of 20 mm, and the sample which is retained on a sieve of 4.7 mm is used for the test. So the soil is mixed with the water to obtain optimum moisture content. So after mixing the soil with water and achieving the optimum moisture content, the spacer disc is placed on the bottom of a mold. This is a spacer disc, so it is placed on a ground, and over this a cylinder is placed. So after placing the cylinder over this disc, the cylinder is filled with the soil sample. So here the soil sample can be filled in two ways. So if it is filled in three layers, then the soil is compacted to a thickness about 44 mm by applying 56 evenly distributed blows from 2.6 kg rammer. So that is the first case. In the second case, for IS-heavy compaction in 5 equal layers of compacted thickness about 26.5 mm by applying 56 evenly distributed blows from 4.89 kg rammer. So here the sample can be uh, filled in a cylinder in two ways. One is in 3 equal layers or 5 equal layers, and for different layers, we have different rammer weights to compact the soil. So after compacting the last layer, the collar is removed and the excess soil above the top of the mold is trimmed off by means of a straight edge. So here you can see a cylinder. So when the cylinder is filled with the soil sample, above a cylinder a collar is placed. So once the compaction job is completed, the collar which is placed on a cylinder is removed. So above this there will be a collar, so that collar is removed and the excess soil is trimmed off using a straight edge. So after that the cylinder is placed on an instrument like this. So after placing the instrument, the surcharge weight is placed on top of the specimen in the mold and the assembly is placed under the plunger of loading frame. So a surcharge weight is placed above a cylinder. So above this surcharge weight, a plunger is placed. A plunger of 50 mm is placed. Then a load is applied on the sample by a standard plunger with diameter of 50 mm at a rate of 1.5 mm per minute. So after all the setup, a load is applied to a sample by a plunger and the rate of loading is 1.25 mm per minute. A load penetration curve is drawn. The load values on standard crust stones are 1370 kg and 2055 kg at 2.5 mm and 5 mm penetration respectively. Graph is plotted to the values which is obtained from the experiment. Here the load values on the soil sample will be 1370 kg for 2.5 mm penetration and 2055 kg for 5 mm penetration respectively. So CBR value is expressed as percentage of actual load causing the penetration of 2.5 mm or 5.0 mm to the standard loads mentioned above. Therefore, CBR is equal to load sustained by the specimen divided by load sustained by the standard aggregates. The CBR value is expressed in terms of percentage and it is the ratio of the load sustained by the specimen to the load sustained by the standard aggregates or standard sample. So here the proving ring calibration factor is noted so that the load dial gauge value can be converted into load in kgs. So from this we will obtain what is the load that is taken by the material. So the two values of CBR will be obtained if the value of 2.5 mm is greater than 5 mm penetration. The former is adopted. If the CBR value obtained from the test at 5 mm penetration is higher than that of 2.5 mm, then the test is repeated for checking. So as I already said you, the CBR value most of the time decreases with increase in the depth. So when the value of CBR is more at a 5 mm penetration depth than that of 2.5 mm depth, we need to cross check the value. If the check test again gives the similar result, then higher value obtained at 5 mm penetration is reported as CBR value. So when we cross check the value for 5 mm penetration and again if we get the same value, then the CBR value is reported for 5 mm penetration and that will be the CBR value for designing of pavement thickness. The average CBR value of 3 test specimen is reported as CBR value of the sample. So 3 samples are prepared and test is conducted for 3 samples and average of 3 results is considered as the average CBR value for the sample.